Okay, as promised, I'm going to build some models with marshmallows and toothpicks to kind of show you where the angles come from. So if you think of each marshmallow as an electron group, of course electrons are negatively charged, so they want to be as far away apart from each other as possible. So if we start with a central atom, which has electrons on it, of course, and then let's say that there are just two groups attached to that central atom, then they're going to want to get as far away from each other as possible, and that's going to be a straight line, a 180-degree angle, and that's as far away from each other as they can possibly get. Now when you add in a third one, and again the electrons are all negatively charged, so they want to get as far away from each other as possible, so they wouldn't want to stay like this because then you have a 90-degree angle. So then they're going to spread out, and as it turns out, as far away from each other as possible as if you're basically dividing a circle into three sections, and so then you end up with a 120-degree angle. Of course, marshmallows aren't negatively charged, so they don't really care how close to each other they are. But now when you add a fourth one, you might think, okay, that's going to be straight up out of the plane, but then if you do that, then you have a 90-degree angle between that one and those that were in the plane, and so they get pushed away, and you end up with the tetrahedral shape where these three aren't quite in a plane. It's a little bit pushed down like an umbrella slightly closing, until you have all of the angles are exactly equal to each other. And my marshmallows aren't firm enough for them to stay in this way, but it's bigger than a 90-degree angle, but smaller than a 120-degree angle, because again, it was 120 degrees, but then it got partially closed as they got pushed down. And that's the tetrahedron, where all of the angles are 109.5 degrees.